Part F, we're asked where's the particle when S is a minimum. So when we're looking at minimums, we have to look at the derivative and find the critical values. We've already done that. Derivative is velocity. We had one critical value. Velocity was 0 when t is 3/2. And notice this is a minimum because we're changing from decreasing to increasing. So from a negative to a positive. So we have a local minimum at 3/2. We want to check the absolute minimum. So when we're checking an absolute, we need to check endpoints. In this case, we were told that t has to be greater than or equal to 0, so that is one endpoint, but then it keeps going on. There is no end, it's going towards infinity. If it said from t equals 0 to 10, then we would be checking 0, 10, and 3/2. But in this case, we're going to check 0 and 3/2. We can also look at what's going on. Our velocity is negative, which means the point or particle is moving to the left first, and then it stops and turns around and goes to the right and keeps going to the right. So we should know just from that and kind of thinking about the problem and the situation is that when t equals 3/2, we should have our absolute minimum. But let's check both just to be sure. If we do s of 0, or position, or initial position, put 0 in there, we're going to get 0 minus 0 plus 2. So we have an initial position of 2 meters. And then we want to figure out s of 3/2. So 3/2 squared minus 3 times 3/2 plus 2. We get 9/4 minus 9/2 plus 2. So we get negative 9/4 plus 8/4. We get negative 1/4. So that is smaller than 2. Negative 1/4 of a meter. That is going to be our minimum position, minimum S.